Hi everyone, I'm Megan and welcome back to another lab video for Analytics and Decision Sciences 4293 Professional Analytics. In this lab, we will be exploring rules of naming variables, as well as the different data types we can have for each variable. If you like the material presented in this video, please make sure you like, comment, and subscribe to our channel. The material presented in this lab will be based on VBA for Modelers, the 5th edition by Christian Albright, and Ivey case 9B11E021 by Wei Zia, which you can find on Ivey cases through the link provided below. Please open Excel and follow along as we get started. So the first thing we're going to talk about in this video is variables and how they are used. Variables keep temporary and changeable information or values such as text, dates, numbers, or various other things that can be used in a macro or VBA code. We have the following rules that are used when naming variables. So the first rule is that a variable must start with a letter. The second rule is that the variable name has to be less than or equal to 250 characters. The third rule is that the variable name cannot be a keyword in Excel. And the final rule is that a variable name must be a continuous string of characters. So on the right here, I have a few different examples that we are going to go through and see if these variable names are valid or not. So the first example, ABCD, it starts with a letter, therefore rule number 1 has been followed. It is less than 250 characters. It is not a keyword of Excel, and the variable name is a continuous string of characters, therefore this is a valid variable name. The second example, we have AB space CD. So this is not a continuous string of characters due to the space, therefore this is not a valid variable name. The third example we have is 3ABDC. So since this does not start with a letter, it is not a valid variable name. The next example is sheet, and this is a keyword of Excel, therefore it is also not a valid variable name. The fifth example is AB underscore CD. So this starts with a letter, is less than 250 characters. It's not a keyword of Excel and is a continuous string of characters, therefore it's a valid variable name. The second last example is dim, which is a keyword of Excel that we will be using later, so therefore that's not a valid variable name. And the final example is myvals, which starts with a letter, is less than 250 characters. It's not a keyword of Excel, and it's one continuous string of characters, therefore it is a valid variable name. Now that we know how to name a variable, the next thing we're going to talk about is the types of variables that we can have in VBA. So first we're going to look at number data types. So the first example we have here is integer, which takes on values within the range of negative 32,768 to positive 32,767. And this data type I find is particularly useful when running loops. The next data type we have is long, which takes integer values from approximately negative 2 billion to positive 2 billion, and this is useful when we need integers that are larger than the values within the integer range. The next data type we have is single, which can have 8 digits, including decimal points. And then we have the double data types, which can have 16 digits, including decimal points. So the single and double are very similar, as is the integer and long. So the long is just larger integers, and the double is larger numbers with decimals as compared to the single data type. Now we have non-number data types. So there are a variety of data types we can have here. String holds any character you want, so letters, numbers, spaces, punctuation, any value that is a character it will hold. And when we set a variable to a character, we need to, or to a string, we need to put that string in quotations. The next data type we have is Boolean, which just denotes true and false values, where true is equal to 1 and false is equal to 0. The next data type we have is an object, which is any object reference in Excel. So that could be a worksheet, a cell, a range of cells, a command button, and there are a plethora of more objects that we could set as this variable data type. And the final data type we have is a date, which can take on any date from January 1st, 100 to December 31st, 9,999, and it is written in the form of month, day, then year. Now that we know how to name a variable and have investigated a variety of different data types, we can declare a variable. So opening up Microsoft Excel as well as Visual Basics, we can do a few examples of declaring variables and then using these variables in a variety of different examples. So to declare a variable, we first write dim, followed by the variable name, then the word as, and following that is the variable type. So for this example, I'm just going to write a macro called decvar, which is going to stand for declaring variables. So the first example we're going to use, we're going to have the data type equal to string. So I'm just going to comment that so we can remember and know what we're doing. So first we need to declare our variable. So we use dim, which stands for dimension. Then we write the variable name. For this example, I'm going to use var underscore string. And then we write the word as, and the data type is string. So now that we have declared our variable, we can use var underscore string in a variety of different settings. So what we are first going to do is we are going to set var underscore string to whatever we want here. And whenever we set a string as something, we need to use quotations. So for this example, I'm just going to write my first variable and use an exclamation point for that. And then I'm just going to have a message box so we can see the output of var underscore string. And run that, we have my first variable, which is what we expect. We just expect the things inside of the quotes. So now I'm going to set var string to the cell A1. So to do that, we're going to use the range object. And then set the value of A1 to var underscore string. And if we run that, we get the same thing as our message box, which said my first variable, which is what we expected. So now I'm going to start using some integers. So now our data type is going to be integer. So we're going to declare the variable. So to do this, we use dim, and then our variable name, which is going to be var integer as integer, which is the data type. So as you can see in cell B1, we have a value of 10, which we're going to use that as the value for var underscore integer. So to do that, we write the variable name and then equals range B1. And then to make sure we are getting a value of 10, we're going to use a message box again. And as you can see, we get a value of 10, which is what we expected. So now we can change the value in cell B10 to be, say, 10.55. So now when we run this again, we are setting the integer variable to a value that is not an integer. So what's going to happen is it's going to round this value. So we should expect in the message box to get a value of 11. So when we run that, as you can see, we get 11, which rounds 10.55 up, which is what we expected. So now we can set their integer to, say, a value of 100,000. So if we go back to what we talked about earlier, the integer variable can only take values from negative 32,000 to approximately 32,000. So this value is outside the scope of that range, so we should see an error when we run this. So yeah, as you can see, we get overflow, which just means that our integer value is outside of the range that it can possibly take. So now if we change the data type to long, which can take, I think it was like 2 billion, from approximately negative 2 billion to positive 2 billion, we should be able to get a message box with the value of 10,000, which we do. So now what we're going to do is we're going to change the data type back to integer and run a loop. So first I'm going to go over to cell B1 and change that to 10, and then we're going to have to change this back to integer. We don't have to because long is larger values of integer, but just for this example, that's what we're going to do. And then we're going to change the value we're going to change the variable var underscore integer to range B1, just for simplicity purposes. And then we're going to get rid of the message box and we're going to declare another integer, which is going to be I. So what I is going to be is that's going to be our looping integer. So we're going to write for I equals to 1 to var underscore integer, and then next I. So what this loop does, it's going to start with I equal to 1 and then run everything that we write inside the for and the next line. And then once it reaches the next I line, it's going to start with 2 and then go to 3 after that and go all the way up until 10. So what we're going to do is we're just going to do a really simple example. So we're going to start by selecting the range of B1. And then from our selection value of B1, we are going to offset I rows and 0 columns and select that cell. And from there, we are going to use our new selected value, so selection, and we are going to set the value of that cell equal to I. And then what we're going to do is we are going to set the selection interior color. So we're going to use the color index object, and we're going to set that to 22. And now I'm going to run this line by line so we can see how it works. So starting, we're going to select the cell B1, which if you look over into this part of my screen, that's where it's going to be running. So we selected cell B1, and now we're going to offset 1 row. So we go down to cell B2. We're going to set that to I, which right now we're doing the first iteration, so that's 1. And then we're going to change the color. So now we're going to do this again. So we're going to select cell B1, and now we're going to offset it 2 rows and 0 columns, so that will bring us to cell B3. Then we're going to change the value in that cell to I, which we're doing the second iteration, so that will be 2. and then change the color. So this will keep happening. So now we're doing 3, we offset it 3 rows, and we change the value. So this will keep going. Just gonna quickly toggle through it. So now we're up until 8, 9, and then our final one, which is 10, and then we finish the macro. So the final example I have for this video is changing the data type to single and double. So I'm just going to get rid of everything we just worked on there and change our data type to single and double. So first we're going to declare a variable that is going to be a single data type. So we're going to call this var_sing, and then set this as single. Then we're going to do the same for var_dub. That's going to be our variable name as double. So now all we're going to do is we're just going to investigate the same number, but in a single data type and a double variable type, or data type, sorry. So we're going to start with var_sing, and we're going to set this equal to 10,000.54321, and then we're going to do the same for var_dub and set that to 10,000.54321. So now what we're going to do is we're just going to have a message box with the output. We're going to start with single, and then we're going to add the var_sing, and we're going to do double, and we're going to add the var_dub. So whatever I wrote in quotes, that's going to be just a text value, and then when we use the ampersand, that is going to call our variable, and it connects the two within our message box. And then the same goes for when we wrote double here, so that's just going to be more text, and then the var double when after the ampersand is going to give us the variable that we wrote. So when we run this, we get a single value where we get 10,000.54, and then a double value where we get all of the decimals. So this is due to the fact that a single data type can only take 8 characters. So we have 5 for the whole number, then we have another one for the decimal, and then 2 more for the 2 decimal places behind it, which equals a total of 8, where double we can take up to 16. So with only 11, we can fit all of the values that we declared into a double, or into this variable that is a double data type. So the next data type we're going to use is the Boolean data type. But before I do that, I'm just going to quickly clear everything that we have on our sheet here because it is no longer needed. So going back to Visual Basics, we can say that we are using, our data type is going to be Boolean. So as we discussed a little bit earlier in this video, 0 is equal to false and 1 is equal to true. So I'm just going to keep this as a comment just so we can remember that and use it when needed. So first we're just going to declare x as a Boolean variable. So what we're going to do is we're going to let x equal 0, which is going to be false. So then we're going to give ourselves a message box of x and just see what that runs. So that gives false, which is what we would expect. Then we can also write in the message box not x, which is going to give us the opposite of 0, which is 1, which corresponds to true. So we should expect the message box to give us an output of true. And when we run that, we get a value of true, which is what we expected. So now to use the Boolean data type in a little bit of a different example, we're going to use an if then else statement. So I'm going to get rid of our message box here, and we're going to do if x equals to 0, then it's going to run whatever we put here. So we're going to say the range of A1, the value of that cell is going to be a false value. And if this is not true, then it's going to run else, and it's going to set the value of A1 to be a true value. And then we have to end our if statement. So when we're going to toggle through this and run it line by line. So first we're setting x equal to 0, and now we're going to run our if statement. So if x is equal to 0, so it's going to check that, and that is true, so it's going to run the range of A1 and set the value of that equal to a false value, and then it ends the if statement. So now if we change x to 1 and run this again, I'm just going to clear the value in cell A1 real quickly. So we're going to rerun this after changing x equal to 1 to see what it does. So first it's going to set x equal to 1, and then it goes into the if statement. So it's checking if x is equal to 0, which it isn't. So it goes to the else portion and runs this line where it selects cell A1 and changes the value to true value, which we can see over in cell A1 there, and then it ends the if statement. So now that we've used the Boolean data type, we're going to move on to an object data type. So to do this, we're just going to delete everything that we got going on here and change our data type equals to an object. So an object can be a variety of things in Excel, but for this example, I'm just going to use a range, as that's pretty easy. So we're going to use dim my object, which is going to be our variable name, and set that to an object. So now, unlike all the other examples that we have done, when we use the object data type and we are going to set it to something, we need to set my object equals to a range of A1 to A10. That's what we're going to use for this example. So the key difference here from anything else we've done before is we have to use that keyword set before putting a specific object to the variable my object. So now what we're going to do is just something really easy. We're just going to set my object equal to a value of 10 and run that. So as you can see over here on the side, we have all the values from A1 to A10. All of those cells are set to a value of 10. We can change this and do a string. So I'm going to change this to object variable. And if we run that, changes all the cells in A1 to A10 to object variable. So for our final example, we are going to use the date data type. And before we do this, I'm just going to get rid of everything in cells A1 to A10. And then we're going to get rid of all of the object example that we just did. So first, I'm going to change the data type in the comment to date. So for this example, we're going to do 3 different little mini examples, I guess. So we're going to have to declare date 1 as a date. So date 1 is our variable name in this example. Then we're going to do the same for date 2 and the same for date 3. So what we're going to do for date 1 is we are going to insert the date by hand. So to do this, we need to put it in quotes. So we're just going to write January 30th, 2021. And then we're going to set the value in cell A1 equal to the variable date 1 that we just wrote. So when we run that, we can see that in cell 1, it changes the form a little bit, but we still get January 30th of 2021. So now doing date 2, that's our next example, we are going to use the date object. So we're setting date 2 equal to date, and then we are going to set cell A2, the value of that cell equal to date 2. So what we're expecting here is the value in cell A2 to change to the date that I am filming this video. So when we run that, we can see that today's date, for me at least, is October 7th of 2021. So then our final example, we are going to use the now object in Excel and set the value of cell A3 equal to the variable date3. So the now object is going to give us the exact date and time that I'm filming this video. So when we run this, we can see that it's still October 7th and I'm filming this video around 2:50. The final thing we need to talk about in this video is the variable scope, which just defines the area that a variable is available. So what we have done so far is we've declared every variable within the sub that we are writing. So this means that these variables, for example, date 1, 2, and 3, can only be called within the sub procedure decvar. So to change this, we could declare the variables, outside at the top of our module. So what this does is we can then create another sub procedure. So we're going to call this guy sub, and we'll do, I don't know, let's use var for this example and end our sub. So since we have already declared date 1 outside of this module, we can just set date 1 equal to whatever we want it. So this one we'll do 2-27-2021, and we'll set A4 equal to date 1. So when we run var, we can see that now in cell A4, the value is changed. So this is just a way to be able to use the same variable within the same module in any sub procedure that you want. The final variable scope that we can have is within all modules that we are creating. So what we can do is we can insert another module here that's going to just be called module 1 for this example. So if we change the dim of date 1 to public, that means that it's going to be available within the declaring variables module as well as module 1. So if we go over to module 1 and write a quick sub called ABC, and then we set date 1 equal to, I don't know, we'll do March 21st, 2021, and then we will set the value of A5 equal to date 1. When we run this, you can see that over in cell A5 we get the date 1 value here, but we didn't even have to declare date 1 as a variable because we had already declared it as a public variable, meaning that it can be used in any module up in the declaring variables module. So this can be very important if you want to use variables in other modules or maybe just in other sub-procedures that you are writing within a specific module. So to just repeat, any module or any variables within a sub-procedure are only defined for that sub-procedure. Any variable defined at the top of a module using dim is defined anywhere within that module. So that could be within any of the sub-procedures that are in the declaring variables module. And finally, if we declare as public, this means that it can be date one, that variable can be used in any module within the workbook that we are working with. This is all the material I have for this video. I hope you found it interesting and helpful when using Excel and VBA for decision modeling. If you like this video, please make sure you like, comment, as well as subscribe to our channel. If you're interested in more videos, please check out our playlist where we describe other ways to use VBA. Thanks for watching. Bye.